So you're really responsible for knowing how to do what? Fractions. You know, and that kind of doesn't change. If you go to Math 125, do they say, oh, you don't have to add fractions here? No. Higher math courses, do they just forget about fractions? No. So what you guys want to invest, again, this problem is not difficult. You just have to remember how to do what? Add fractions. In fact, it's so nice. What kind of fractions are these?
Like.
These are like fractions. Well, how do you do that? What do? Isn't this really negative 4 plus 1? You add the numerators. That negative sign belongs to what? That 4? Negative 4 plus 1 over 21. What's negative 4 plus 1? Is that negative 3? So let's continue our work over here. So what's negative 4 plus 1 again? Negative 3 over 21. Now you guys remember, what do I do with that negative sign? Put it at the same level. Do you guys remember why I do that? So I can now simplify my what? Fraction. So how do you simplify 3 over 21? Right, because 21, again, is 3 times what? 7. Divide by 3, you got the what? 7. So we get x is greater than negative what? 1 over what? 7. You always simplify your fractions. Yes?
I got a question on translation here. X is more than negative 421. Won't we change the negative to a positive?
Which one?
When we translated the first one, the 421.
Well,
will it be plus 421?
Did you move that fraction?
Yeah, I moved it.
Oh, you did? Negative 4 over 21 is moved? Which one did you move? When you translate, aren't you moving this? See what I'm saying? So you don't move that one, or you don't change that sign. That sign is the same. So you're only changing the sign of the term that you moved to the other side. And again, you only translate when you have addition or what? Subtraction. Okay? So anyway, here we go. Here's our solution. And what does this mean as a set? We say the set of all x such that what? X is greater than negative 1, 7. How does the graph look? Here's 0. Where's negative 1, 7th at? Is that to the left or to the right? Open circle, shade everything to the what? To the right. And then how does the interval look? Negative 1, 7th up to what? Infinity. Parentheses. And then what do you do about this? In the back of the book, you may see what? They don't put the open circle. They'll put the parentheses. What does that parentheses signify? That you don't include the what? The number. How do you know you don't include the number? There's no equal sign. So here's your graph, here's your set notation, your graph, and here's the interval notation. So these are the 3 type of answers that they ask you for. And if you guys took a look at the worksheet, didn't you notice they asked you for those 3 type of answers? Yeah. So they want to test you on all 4 concepts. Can you solve? Can you describe the solution in the different notation? Okay, so take a look at this example. Here's another very famous issue that I want to have to deal with. Is what if you have negative 3x, for example, is greater than or equal to, let's say, negative 12. So you got negative 3x. What does that mean? Is that negative 3 times x? Okay. So tell me, how do you undo multiplication to that x? Good, you divide. Now, what do you always divide by? The number doing the what? Multiplying. What number is multiplied to x? So you're going to divide both sides by what? Negative 3. Okay? All right, here we go. What happens with that division then? It's gone. What do you have left? X. There's an x. What's the sign here? Let me talk about this. Some of you guys may know, and we'll see why. When you divide both sides by a negative, what happens? You switch the signs. You say, what do you mean switch the signs? Well, you switch directions. Okay? We're going to see why. And then, what's negative 12 divided by what? Negative 3. Is it positive 4? Okay. We have solved what? We have solved this inequality. Yes? Yeah, let's talk about what? Let's talk about why. Why do we have to change the sign? Okay? So let me go through with you here a sort of, a sort of process here as to why. For example, what if I said to you, if we had to compare two numbers like 10 and 15, which one's larger, 10 or 15? Is it 15? So how would JAWS open? JAWS opens to the bigger number, right? JAWS is opening to the 15. 15 is larger. Now, what if I said to you, what I want to do now is I'm going to now divide what? Both sides by a negative number. I know 10 is less than 15. But if I divided both sides now by, let's say, negative 5, isn't that a negative number, negative 5? You guys tell me, what's 10 divided by negative 5? That's negative 2? Okay. What's 15 divided by negative 5? Is that negative 3? Okay. So who can tell me what number is bigger? How is JAWS going to open? Is JAWS going to open to the negative 2 or the negative 3? JAWS opens to the negative 2? How do you know JAWS opens to the negative 2? Because when you go and you try to find the larger number, right? You're going to deduce this. If this is 0, you got negative 1, negative 2, negative 3. Here's negative 2. Here's negative 3. So negative 2 would be right here. Negative 3 would be right here. Which number is on the right? Negative 2. So that one is what? Larger. What happened with the sign? It switched. So the moral of the story here is this. When you divide both sides by a what? Negative. Is that still on? Do you know? Let me know if it turns off. When you divide both sides by a negative, what happens to the sign? You switch the sign. So when people say, why does the sign switch? Or why did we have to do that? Well, it's because what? That's the situation. That's how it is. So when you divide by a negative, what happens to the inequality? It changes direction. You see what I'm saying? Notice this also. What if I said to you, you already know 10 is smaller than 15. Give me another number. What's your favorite number? 13. Give me another one. 7. Give me a negative number. Negative 7. Let's take negative 7 and multiply it to what? To both sides. Negative 7. Okay, now times what? 10 times 15. What's negative 7 times 10? Is that negative 70? What's negative 7 times 15? 105. Negative 105? What happened now? Who do you guys know? Where does JAWS open? JAWS opens to the bigger number. Which one's the bigger number? Negative 70. Good. What happened? Switched. So here's what I want to say to you guys. Here's a fact. Here's really what I want to... Let's write it over here. If you multiply are what? Are divided by a what? By a negative number. And that's really for both sides, right? Because you're really doing it to both sides. Just to remind you. Then what do you have to always do? Switch the what? Switch the directions of the what? Signs. You switch the signs. So I'm going to recommend to you guys, even in your notes, to make sure you write that. Maybe you went and you purchased this weekend, or maybe you already have a red marker. You know, how you study, in all honesty, for some of these concepts, is that when you work on these problems, you switch the signs. You mark it in red. And if you're going to divide by a negative, you mark it in what? You mark it in red. Oh, we're not done. What was that answer? We didn't graph this, right? We didn't write it as interval notation. What was the, what do we have here? X was what? X was less than or equal to what number? 4. What's the set notation? Set of all x, such that x is less than or equal to 4. You do the graph. 0, the reference number, 4 is where? It's positive, so it's over here. Is that a closed circle? Shade everything in what direction, left or right? Well, we have to shade numbers that are what? Less. What are numbers that are less than 4? To the left or to the right? To the left. What about interval notation? How do you start interval notation? Start on the left. Are your feet in water on the left over here? So we're starting at negative infinity, and we're walking all the way up to what number? 4. I'm going to have to put what? A bracket. Why do we put that bracket? We put that even in red. What does that mean, to put the bracket? You include 4. How do you know if you include 4?
It's shaded.
Well, it's shaded. Why do we shade it? Equal. Equal. Solution, set notation of the solution, graph of the solution, interval notation of the solution. So that information drives all 3 concepts. Okay, you guys okay with that? This is really what they're testing you on, all 4 of these things. And then, let's look at a couple more examples here. How about this? Let's give you a couple more examples. How about this? What if you had negative 2/3 x, okay, greater than or equal, if you want, you go that way, greater than or equal to, oh, how about 18? Okay, you guys okay with this? So, what do we do with this? How do we handle this? Huh? You translate? Well, maybe. How would we do the following? Do you guys remember, if this was an equality, that was an equation, right? And then you just had a fraction times that variable. What would you do to get rid of that fraction? You multiply both sides by the reciprocal of what? Of 2/3. What's the reciprocal of 2/3? 3/2, is that right? But because this is negative, what I'm going to say to you is multiply by the reciprocal, which is also true, but make sure what? You put the sign being negative. Now, it's a negative 3/2 to both sides. Let me do this. Negative 3/2 to both sides, okay? Now, because you know you're multiplying both sides by a negative, let's kind of look at this in a lot more detail. If you really look at this, this kind of looks ugly. I don't even know what's going on. Why, ladies and gentlemen, do I need to put parentheses? Remember I talked about that before? That we put parentheses around what? Negative numbers. Why do we do that? For emphasizing the numbers negative, and we are probably what?